everyone. Here we have a question 10 kg of R-134 at 300 kilopascal fills a rigid container whose volume is 14 liters. So if we write down a given data first, mass is equal to 10 kg and pressure it is given, let's say P1 it is 300 kilopascal, 300 kilopascal and volume, initial volume V1 it is given as 14 liters. So you can convert it into meter as 0.014 meter cube because 1 liter is equal to 0.001 meter cube. So we need to find out the temperature T1, determine the temperature T1 and enthalpy H1 of mixture. So the container is now heated until pressure becomes 600 kilopascal kPa and we need to find out the temperature T2 final state and enthalpy when the heating is completed. Total enthalpy we need to find, so we need to find out the here H1 and here we need to find out the H2. So initially we find out the specific volume V1. V1 is equal to volume divided by mass. V1 divided by mass, so it will be a 0.014 divided by mass 10 kg, so it will coming around 0.0014 meter cube per kg. Now we can compare this V1 at P1 is equal to 300 kilopascal with respect to Vg and Vf. So Vf at this point it will be, let's say Vf1 it will be 0.00773 meter cube per kg. This value we got from R-134a table and Vg1 you will get as 0.06778 meter cube per kg. So if we compare this V1 with respect to Vf1 and Vg1, this will be Vf1, V1, Vg1. So V1 is greater than Vf1 and Vg1. So it is a liquid plus vapor mixture. It is liquid plus vapor mixture. It is within the dome. Liquid plus vapor mixture. It will be within the dome, so we can find out the dryness fraction first. In order to find out the dryness fraction, we can use the formula V1. This is the specific volume, same like this. So I am writing V1. This will be Vf1 plus, or you can write down V1, Vf1 plus x Vfg. This value it will be coming around Vf1. It will be, we need to find out the x, so it will be a V1 minus Vf1 divided by Vg minus Vf. So V1 we have already value as 0.0014 minus Vf1 it will be 0.000773 divided by Vg it will be 0.06778 minus 0.000773. So if we calculate this value, it will be coming around x is equal to, you can say this is x1 or x, it will be a 0.000627 divided by 0.06707. So, and dryness fraction at initial stage, you will get as 0.00935. Using this dryness fraction, we can find out the enthalpy. The enthalpy you can find out at 300 kilopascal. It will be HF1 plus X HFG1. So in this R-134 table, P1 is equal to 300 kilopascal. You will get HF1 as 7 point HF1, it will be around 52.71, 52.71, and HF1, and this will be HFG1. HFG1, it is coming around Hg1 minus Hf1. It will be a 250.88 minus 52.71. So if you put this value here, you will get as H1 52.71 plus X is a dry inspection 0.000935 into 250.88 minus 52.71. So around H1 value you will get as 0.56 kilojoule per kg. Now at 300 kilopascal, if uh, total enthalpy H is equal to M into H1, this will be a 10 into 54.56 kilojoule per kg. So H1 around you will get as 545.6 kilojoule. That is your total enthalpy. And also we need to find out the temperature. You can find out Tsat from the steam table at 300 kilopascal. It will be around 0.65 degrees Celsius. Now it is heated to a final pressure P2. It will be around 600 kilopascal. So at 600 kilopascal, we need to have another property. As it is a rigid container, it will be a constant volume process. It is a rigid container, so it will be a constant volume process. So V1 is equal to V2. So V2 you will get as 0.0014 meter cube per kg, and if we compare at 600 kilopascal, you will get Vf2 is equal to 0.000820 meter cube per kg. Vg2 you can get the value as 0.03433. Here also same case, Vf2 is less than V2 is less than Vg2. It is also liquid plus vapor mixture. It is also liquid plus vapor mixture. Vapor mixture. So again, you can find out the dryness fraction. So x2 is equal to Vf2 plus, sorry, this will be V2, you can say V2 Vf2 plus X Vfg2. So you can find out dryness fraction at state 2. It will be a V2 minus Vf2 divided by Vg2 minus Vf2. So you can find out the X as 0.0014 minus 0.008198 divided by 0.03433 minus 0.008198. So finally you will get a dryness fraction around 0.01731. Now at P2 600 kilopascal, 600 kilopascal enthalpy, you can find out the enthalpy as H2 is equal to HF2 plus XH HFG2. Now I will write down direct value of HF2, which is 8150 plus 0.01731 into 180.95. You will get the H2 value around 84.64 kilojoule per kg. Now if we do total enthalpy, it will be M into H2. So M into H2, it will be 10 into 84.64 will be around 846.4 kilojoule. So my question to you guys, what will be a T2? So I will just give the hint. So if you draw a PV diagram, pressure volume diagram, so this will be your dome. Here initially it is the same dryness fraction, uh, dryness fraction as x1. It is heated at a constant volume. You will get this as a point 2, this as a point 1. So this is in the liquid plus vapor mixture. So my question, what will be the T2 value, guys? So just will revise this answer. So here mass it is given as a 10 kg, pressure P1 it is 300 kilopascal, V1 it is given as a volume 0.014 meter cube. We need to find out initial temperature T1, total enthalpy at state 1 and total enthalpy at state 2. So we first find out the specific volume using volume divided by mass, and we compare this with the Vf1 and Vg1, and P1 is equal to 300 kilopascal. We found that it is V1 is greater than Vf1 and it is less than Vg1. So we found out the dryness fraction X. Using this dryness fraction X, we have calculated the specific enthalpy using formula of 1 plus XHFG1. We found out the value of enthalpy around 54.56 kilojoule per kg, and total enthalpy we calculated as a mass into specific enthalpy, which is 545.6 kilojoule, and the saturation temperature 0.65 degrees Celsius. Same way, it is a rigid container, constant volume process. It is heated at a constant volume. So we found out the VF2 and VG2 at a P2 is equal to 600 kilopascal. So again, we found that it will be a liquid plus vapor mixture. Again, same procedure. We found out the dryness fraction. Using this dryness fraction, we have calculated the enthalpy. In that enthalpy, using the mass, we found out the total enthalpy. This is the answer. And also, my question to you guys, what will be the final temperature T2 here? So, thank you.